All right, as promised, here's another method of creating a three-sided surface. So in the prior video, you saw me, I created this and then put another blob over here, and then we got a discussion as to why it's so heavy. And there's other things I need to talk about in regards to that, like using a 1-degree spline, blah, blah, blah. All sorts of interesting things are going to come out of that. But anyway, right now, we're dealing with three-sided surface again. And, there were ways that you could build it all the way across and chop some out and put in a patch and so on and so forth. Things get complicated again because we're going from a circle to a NURBS, but, there's ways around that. If I were to put in a NURBS element here and then try to get it as close to the circle, I could minimize that, but I'm not going to do that. I'm going to use the circle. Now, I threw in this patch here. Let me show you the control polygon. So it's a fairly simple patch. And again, the complexity is there because this is a line. This is an arc here. This is a line in the sketch. And again, this is the, let me pick this. Let me show the control polygon of that. And so now we're using only a portion of, so what I did is I split this to a plane that's radial to this curve to get that shape. Now, I built that surface. So yeah, it's a little bit more complex than I would like. Again, that's because I'm using partial curves with a line, which is a non-NURBS element. So one way you can go about building is this curve I took, and I made it as a offset curve in face from this curve. So I just basically ran it along this length. This is an isoparametric curve. I just put it at that point, split this one with that one, and then I did a bridge curve, laying that bridge curve down on that surface. Okay. So this now, as you can see, has the four sides that all good surfaces want. So this is another method of building a four-sided surface. And quite frankly, I would say this one probably gives me the cleanest results for highlights and stuff. So we'll go through and make that surface. And again, there's various ways you can go about making that surface. And for this, I will use through curve mesh because that is what the original question was based off of. And I'm going to use a single curve, section 1. And yes, I want tangency down here. Section 2, single curve, stop. And it's going to stop here because that's where I want it to stop. And then that is also going to be a tangency to this. Now my cross curves. So for my cross curves, I want this, and I want, excuse moi, this curve. And this is going to be tangent to this face, and this one we'll leave at G0 for now. And you get, as you can see, a very nice surface. So this surface is again built off of a circle. And because it is built off of a circle, whoops, and how to do things. I hit the wrong button. There we go. We end up with a very, very complex surface because, again, this is a circle. NURBS have a propensity to do that so that this is going to be as complex. Now, if I double-click on this and I look at some of the other options in here, I have both. I have normal, I have primary, cross, right? This is the emphasis on what? I'll say emphasis on the primaries. Didn't really change anything. Construction, let me go to simple. Maybe I can simplify that a little bit, which in this case it did. If I have templates, I may be able to use a template, but I don't want to do that because it'll start really breaking away tangencies, and in this case, I can't do that, okay? But by futzing around in here a little bit, I'm able to, as you can see, get a slightly simpler, well, I wouldn't say slightly, it's fairly big change as far as the level of complexity in the surface, okay? Now, I'm going to go ahead and trim my sheet. I'm going to trim this to these objects. I do not want to extend the boundary. I want to trim this. Whoops, I don't want tangent curve. I want single curve. I want this guy. And then turn on stop at intersection to that guy. The region to keep is over here. Select OK. Let me turn all of this off. And now, let me go ahead and just hide that. How good that looks. All right, looks really nice. I'm going to go ahead and throw on some highlights. And we have a very, very nice looking set of highlights coming down and around here. Now you'll notice there's slight little breaks. Again, this is just flowing in tangency. We expect to see that. Again, this is an arc, a very complex NURB surface. This is in this direction, it's basically almost linear. And so you kind of expect to see stuff like this, but there are little things that you can do to clean that up a little bit, right? So if I wanted to, I can come in here and say, all right, well, I want to take this curve and I want to pull it back a little bit, right? Maybe stretch out whatever it is that is causing the little disruptions that we don't like. I could also play around with this bridge curve. Go to details, right? Right now it's 0.1. Maybe I want to flatten it out a little bit. 9.9. And just massage it and maybe go the opposite direction. 1.1. Give it a bit more of acceleration. Okay, maybe it's not giving me really what I want. You can really see the difference as I undo and redo and go back to the original. Okay, there may be cause for me to double click on that and go, well, you know what, maybe I want to change this from G0 or G1 to G2 and see if that does anything for me. And right, it just kind of pushed that error out a little bit. And again, I expected to see that. And again, the reason why is this is an arc going into a line. This is a line coming down. The surface is basically linear coming down here. So we do have some linear elements, and that's what we expect to see when we get into linear elements, because I cannot go to G2 across this boundary. This is not possible. Won't do it. Over here, it's fine. Right? This is at the rate of curvature, right? This is basically G3. It's just imposed because in this direction, this is just on the surface. Same thing with this curve. In this direction, that, this is one big, long, general, very simple spline. So if I pick that, turn on my control points, you'll see it's a very simple spline. So, everything else is great, but basically what I'm doing is I'm fighting where I am putting this, because again, this is a line going into an arc. Now, if I could, I would add the slightest bit of crown to this. When I say slightest, I mean, we're talking absolutely minuscule. Maybe a 1,000, 2,000, 5,000 radius, depending on the size of this. And then, do the same thing, or maybe just a conic that's almost perfectly flat, right, through those 2 points, like bring this point in just a hair, just to get a slight bit of acceleration. And then do the same thing with this, maybe use a conic to try to get that shape and mimic it as closely as possible. And that way I could potentially end up with G2 or something that looks like G2 because I fudged it in using 2 conics, or put in a spline that is actually G2 across that boundary. So that way when I make this surface and it flows into it, this does go G2. Okay, but that is the constraint that we have, and that's just what we have to work with. But that is another way to build your 3-sided surfaces. And this is, in general, probably I would say the best way, because it overall it's going to build the least complex of them all. Let me go to here. And if you go back and reference that other video, you'll note that by far this is probably the smoothest and least complex method for in scare quotes, 3-sided surfaces.